Hello, fourth grade. Welcome back to another episode of Bath Math. I just want to take a second and celebrate you guys. You all grew exponentially in all of your MAP tests that you took. To grow 460 some points, 580 some here, 400 and something here as a collective fourth grade team was amazing. Miss Dale, Miss Poyatos, and I can't stop cheering you on and us on, and just it's so affirming that even though this year hasn't been ideal, we're still killing it and we're still growing and we're still learning. So that's awesome. This week we are jumping into input-output tables. And they're kind of like magic machines. And I'll get to that in a second. But this unit is really short. After this, we'll be jumping into fractions. I just want to take a second to kind of go over some key pointers and tips to help you with this week's assignments. So let's jump into it. These are the essential questions and sentence stems for the week. Pause the video to read over them, but they are also available on your Math Blend page. Here is the vocabulary for the week. Feel free to pause the video to read over the words and see if there are any you may not know. Okay, so bear with me. This looks like a lot. I'm going to go through it slowly. Feel free to pause and rewind just to make sure that you're on track. Input-output tables. Use the words, the vocabulary words within that to make sense of it. What's coming in is going out, and it's in a table form, okay? It consists of paired numbers. So pairs, there's always going to be just two numbers that follow a rule. You have to figure out what that rule is. The output value depends on the input value. So let's look at these boxes. The input is the first column, so the number that you first have. The output is what is next to it. So if my input is 12, my output is 23. What is the rule? And here's the thing. The rules can be whether you're adding something, you're subtracting something, you're multiplying something, or you're dividing something. Right? You have to figure out how much you're adding, how much you're subtracting, how much you're multiplying or dividing. So within this, it's super important, you know how to do all of those functions. But now it's the game of figuring out what is happening in this little magic machine to create or to make these numbers in the first column, these numbers in the second. What you're putting in is coming out differently. Why? What is that machine doing? So let's look at this one. 12 to 23. Okay. This 12, I could maybe multiply it by 2. No, that would be 24. That's not multiplying by 2. If I divide, that would make it smaller. So it's not division. It's not multiplying by 2 or more. If I multiply it by 1, it's just 12, so I can't do that. So maybe I'm not subtracting anything because it's a bigger number. So I'm eliminating which rules it could be that don't make sense. So it looks like I'm with adding. What would I be adding? So let's see, 12 plus 12 is 24, so 12 plus 11. Now, I'm guessing that that's the rule. The rule has to apply to each of the numbers given. So if it's plus 11, that might be my answer, but I need to verify that that works with each one. So 16 plus 11, yeah, is 27. Okay. 20 plus 11, yes, 31. 25 plus 11, 36. I've figured out the rule. The rule is plus 11. Okay. Let's look at the next one. 18 turns into 6. Okay. I put in 24, it turns into 8. I put in 36, it turns into 12. I put in 90, turns into 30. The numbers are getting smaller, so I'm definitely not adding anything, and I'm not multiplying either. It's going to be either subtraction or division. 18 minus 12, if I do minus 12, well, that gives me 6, but 24 minus 12 gives me 8, and that's not correct. So the rule can't be subtracting, so I'm going to guess that it's dividing. 18 divided by 2 is 9. That doesn't work. 18 divided by 3, yeah, that's 6. Does that work for the others? 24 divided by 3, yep, equals 8. 36 divided by 3, yep, equals 12. And 90 divided by 3 equals 30. So the rule was to divide by 3. Okay, let's look at the last one. Boxes and eggs. So I did A, B, in, out. Let's try like a real world situation. If I give you one box and it has 12 eggs in it, I give you two boxes and it has 24 eggs in it. What's happening here? So the number seems to be getting bigger. It's not division or subtraction because that would make the numbers smaller. So I'm going to guess that it's addition or multiplication. If I add 1 plus 11, it turns into 12. 2 plus 11, that's not 24. The rule has to be the same for all the numbers. So maybe times 12, because 1 times 12 is 12. Okay, so times 12. 2 times 12 is 24. Yep. 3 times 12 is 36. Yep. And 5 times 12 is 60. So my rule here is times 12. So a couple of tricks from what we just did. You have to figure out the rule. So you have to kind of see what's happening. But the rule has to be the same for each of the numbers that you put in and that you put out for those for that machine. So this was, consider this like one magic machine. Whatever was happening here on one side, it passed through the same rule to get to the other side. Okay, and I'll break that down in a little bit more in the next couple of practice problems. Okay. Okay, I want to take a moment before I jump into practice problems for input and output tables, and I want to go over what a numerical expression is. It is, they're like equations, but they're a little different. They represent a single value, and it consists of one or more numbers and operations. So these are just some examples of numerical expressions. It's just kind of like the work that you need to do to get to a particular answer, right? So when we have the input number, let's say it's 1, and I have the output number, I don't know, 100, I have to figure out what is happening in that machine, right? And so what I did in the previous clip was kind of write over or in the middle of those boxes what that rule was. That is a numerical expression, right? I am making another column in between to figure out what is going on within those boxes. So I'll show you in a bit how you can do that for yourself whenever you do have an input-output problem, and especially for this week and all of your assignments. It's just creating another column in between to figure out from the input to the output, what is that machine doing? That would be your numerical expression. So let's jump into that in a second. But again, these are just some examples that you would maybe come across in, like this would be algebra, in case, you have bigger numbers in the input side, sometimes you will. And sometimes they'll be small, like 1, 2, 3, 4, 5, or sometimes they'll be like in the thousands range and you have to kind of figure out what's happening. All that being said, please feel free to use your multiplications chart, your strategies from division, and then take a moment to make sure that that rule applies to all of those numbers. So again, let's jump into what that looks like if I were to lay it out, okay? Okay, here's an example of what the numerical expression would be. Let's say we don't know the output. The question might ask you to generate a pattern and to fill in this machine to see or to get to a particular answer, right? So the example is Stella is 2 years older than her sister. Okay, so we're talking about Stella. We need to figure out how old she is. Create a table to generate a pattern until her sister turned 4. So her younger sister is the input. So her sister is 1, 2, 3, and 4, right? Stella is 2 years older, so we need to figure out how old Stella is while her sister is 1 year old, 2 years old, 3 years old, and 4 years old, right? My numerical expression is what is happening within that machine to give us that output. So my input is her younger sister's age, 1, 2, 3, 4, because it says until her sister turned 4. So all the years before 4. Stella is 2 years older. That is the rule. It's already giving you the rule. Stella is 2 years older, meaning 1, my numerical expression would be Stella's age is 1 year old, plus 2 gives me, Stella's sister's age is 1, plus the 2 years, because Stella is older, that makes Stella how old? 3. Okay? All we did was get an input. We have the numerical expression telling us what to do, and that gave us an output. Now I know that that's Stella's age. You're thinking, Ms. Diaz, this math is super easy. Yeah, but you're going to get problems that are going to make you do the same thing, that are going to be higher in range, or a little bit more tricky. I just want you to have the basis of how an input-output table works, right? So again, her younger sister is 2. When she was 2 years old, we would add that age. So I have her 2 years old plus the 2 years of her being older. That would make Stella 4. Excuse me. Yeah, 4. Okay. Her younger sister was 3 plus the 2 years of age. That would make Stella 5 years old. So at the same time that her sister is 3, Stella is 5 years old, right? At this, her younger sister is 4 plus the 2 years of age. That would make Stella 6 years old. So in my answer, I would say that Stella was 3, 4, 5, and 6, while her sister was 1, 2, 3, 4. But what happened here, the rule was to add 2 in my input-output table, and I'm showing you the numerical expression, showing you my work, how I got there, right? I added these numbers plus the rule, and it gave me these answers, okay? And the same rule applied in each row with each input-output, okay? Hopefully that helps understand where the numerical expression lies. It's as if we put the input and output together and this kind of folded in inside. You can always just open that up, draw out your box to include this third column to make sure that your work makes sense and that the rule is the same in every single row. Yeah, but let's get into more practice problems and hopefully this will start to click and make sense. If it doesn't, go back, rewind, watch it again, or let me know during the Zoom calls, okay? I laid out a similar chart or box or machine, if you want to call it, and it gave me the input of 1, 2, 3, 4 and the output of 4, 8, 12, 16. That's what the problem gave me, right? So it drew it out and it just had it in 2 columns. I guess I should have drawn that, but basically the problem gave it to me in 2 rows, right? It said in, out, and then 1, 2, 3, 4, and then 4, 8, 16, no, kidding, 12, 16. What I did was I redrew it to include my numerical expression to figure out what the machine is doing. How are these numbers turning into these, right? So this is where kind of the fun guessing comes in. And remember, the rule can be either addition, subtraction, multiplication, or division. And subtraction and division will always make the numbers go smaller. Addition and multiplication will make the numbers go bigger. So immediately, just from saying that, these numbers are getting bigger. So we're not going to be using the subtraction, we're not going to be using the division. It's going to be either addition or multiplication. That makes my job a lot easier to figure out what that rule is. So let's try adding. Maybe it's addition. 1 plus 3. Okay, if I did that, it gives me 4. 2 plus 3 gives me 5. That doesn't work. So because the rule has to be the same all the way down. So it's not adding, so I have to figure out what it's multiplying. 1 times 4 gives me 4. Yep. 2 times 4 gives me 8. Yep. 3 times 4 gives me 12. Yep. And 4 times 4 gives me 16. So I have found the rule. The rule is times 4. If the question is asking you that, then that's it, right? You figured out the numerical expression to get from the input number to the output number, and the rule was the same. But There might be a question that not only asks you to figure out what the rule is, but the answer isn't what's the rule. So now that we have the rule, I'll put this up here, times 4. But it might ask you to fill in the output, so this number, for perhaps the input of 10. So you can continue creating more numbers. Sure, you can go 5, 6, 7, 8, 9, 10 if that's helpful. Excuse me. Or because you figured out the rules in these, it allows you to place the same rule here to get that output. So following the same rule, 10 times 4 equals 40. My answer is 40, right? So part 1, or a question could ask you, what is the rule? You figured that out. Or questions can ask you, what is the output of a certain number? And you have to apply that same rule to get that answer. So just to make sure that you are aware of both types of problems and know the steps to get there. So input, output, it's going through a machine. What's happening in that machine is the numerical expression. What is the rule of that machine? And how can you get to the answers that you want by applying that rule to each row, okay? Let me know if you have any questions during our Zoom calls, please. Here are some extra tools for working on division. I hope that they help support you and bring a little bit of your classroom into your home. These are tools we would have used or anchor charts we would have gone over in class together. This is a great time to pause the video and check each one out. Thank you all for watching another episode of Bath Math. Please remember that you can always go back and watch any part of this video again or the whole thing again, and check out those extra tools and supports because those are really helpful in just kind of making sure that you're on the right track and that you're understanding. And if you're not, let me know during the Zoom call. That would be a perfect time to let me know if you have questions, if you're confused, if it's not making sense, and we can work on it together. So hope you all have a great week, and I will see you on Zoom. Bye.